Hello students and welcome to the lecture. So students, as you can see here, that basically in this lecture we are going to start the discussion over the new topic. This is the elasticity. Okay, it is a topic we are going to talk about, and basically we will do the discussion as the part one. Okay, so that is going to be our part one of the elasticity. Okay, basically in this lecture we will discuss about some terms that are related to the elasticity. We will talk about the stress, not a psychological stress, but what is the physical stress. Okay. So whenever we talk about the stress, generally it comes in our mind that we always go to the psychological ways, but it's not like this. Basically, we are covering the physics. So here, when we talk about the stress, we will talk about the physical stress, not a psychological. So this is the thing which I wanted to make clear in your head so that you should not get confused further. Okay. We will also talk about type of stress. We will talk about strain, types of strain, elastic limit, what do you mean by this, Hooke's law, and at last, we will see the summary of all this. So this is going to be the, you can say the way of discussion for us, starting with some terms related to elasticity, stress, type of stress, strain, types of strain, elastic limit, Hooke's law. Okay. But before starting the actual topic, as usual, we have our small disclaimer over here that we are required to understand first before we proceed further. Okay. So the disclaimer is like the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, then please contact us at sathi@iitk.ac.in and we shall remove the image. Okay. Now let's talk about the some terms that are related to the elasticity. But before this, we must be aware about the elasticity. What do we mean by it? Then only we'll be able to talk about the terms that are related to it. So basically, if I ask you like what do you mean by the elasticity? So here in this picture, you can go by this that elasticity is actually the property of the body by which it regains its original shape, size after removal of external force called as elasticity. So now you can say, suppose you have two balls with you. One is spongy ball, another one is you can say light plastic ball. Okay, so now you having these two balls in your hand. You start crushing them or you start exerting a pressure, external force on them. So what will happen? After some time, you will notice that the light plastic ball will get you can say shrunk because of the crushing action of your hand. Okay, and once you remove your hand from that ball will not be able to regain the original shape and size. You have withdrawn your force, like you are not crushing it anymore. But still, you will find out that the ball is not getting the regain or not regaining its original shape and size. On the other hand, contrary to this, the spongy ball that you had, you also did the same thing on that spongy ball. You pushed it with your hand. Okay, you tried to crush it, but for the time being, it also shrunk. Once you remove your hand, okay, once you stop putting that external force over that ball, what you will see, that ball regain the original shape and size. Okay, so now you can say two scenarios we have. We have two balls. One ball after crushed couldn't regain its original shape and size. One ball, on the other hand, after crushed, regained its original shape and size. So that is known as the elasticity. Okay, like it is the property through which the body or any particular object could gain their original shape and size once the external force is removed. So that spongy ball is actually the elastic ball. Like once you remove that external force, that ball gain its original shape and size. Okay. Now, first term that is being related to this elasticity is the deforming force. So, what do we exactly mean by the deforming force? It is a force applied on a body, produces a change in the normal position of the molecules of the body, which results in the changing configuration of the body either in length, shape, volume. Then the force applied is called the deforming force. Like you can say, if you are seeing any object, for example, if you are seeing that particular ball, that spongy ball, okay. So what you are seeing that that ball is a circular, solid circular shape, okay. It's having a solid circular shape, which means that the molecules are arranged inside that ball in a manner that it must be appear as a solid circular shape. So now when you are trying to crushing it, when you are putting a pressure through your hand on that ball, then what will happen? The normal position of the molecules that is arranged in a manner that it must be a solid circular ball will now be dismantled, and it will be like you can say spherical, flat spherical ball. Okay. So which means length of the ball will change, volume will change, obviously, shape will change. Okay. So that crushing force through your hand which you had applied on the ball, that is known as the deforming. Like any force that is being applied on an object through which the normal position, or you can say the arrangement of normal molecule position will get changed. So thus the configuration of the body will change either in length, volume or shape. Then it is known as the deforming force. Got it? Thus a deforming force is one which when applied changes the configuration of the body. Okay, like as I've told you, a solid circular shape you are seeing. Once you applied the uh, crushing or deforming force, what will happen? The normal configuration of that circular ball will change into a spherical ball, a flat spherical you can say. Now, elasticity. Actually, the property of the body to regain its original configuration, whether in terms of length, volume, or shape, when the deforming force removed is called elasticity. Like the circular ball that you had, when you are putting a pressure on it, when you are putting a force on it by the help of your hand, so basically you are changing its configuration, original configuration in terms of length, volume, or shape. Okay. And when you will stop doing it, when you release the force, then deforming force will be removal. Okay. Again, the body will gain original configuration in terms of length, volume, or shape. Right? That is known as the elasticity. Now, perfectly elastic body. Actually, it's a body which regain its original configuration immediately and completely after the removal of deforming force from it. It's called the perfectly elastic body. Like suppose you are having any particular object, for example, you are having a rubber band. So if you see the rubber band, you will find out that that is having some kind of circular shape. Okay. So if you stretch it further, you will changing its configuration. Okay. Like you are applying a external force on it. But once you release the pressure, what will happen? Immediately, the original configuration will be taken by the rubber band. Okay. So that's why we called rubber band as a perfectly elastic body. Why? Because it's having the ability to regain its original configuration immediately and completely after the removal of deforming force. Okay. Now, perfectly plastic body. What do you mean by this? So a body which does not regain its original configuration at all on the removal of deforming force, from it is called the perfectly plastic body. For example, if you're having a light plastic ball is also originally, if you go by the configuration, was in the solid circular shape. In which shape? Solid circular shape. Okay. So once you applied the crushing of that ball through your hand, so you are applying a deforming force on it. Okay. So what will happen? The original configuration of the plastic ball will get changed completely. That will happen. Okay. And when you release the pressure, when you are not no longer applying the deforming force on it, then what will happen? Is it possible that that plastic ball will regain its original shape, original size, original length, volume? No. You will find out that plastic ball is unable to regain these configurations. So that's why this is known as the perfectly plastic body. Because even after the removal of the deforming force, that body is not able to regain the original configuration at all. Whereas in perfectly elastic body, once the external or deforming force removes, the body having the capability to originally give the configuration immediately and completely. QT mud and paraffin wax are the example of nearly perfectly plastic bodies because once the deforming force removed from them, they are not able to regain their original shape, size, and volume. There is a note. In fact, no body is perfectly elastic or perfectly plastic. Only the degree of plasticity differs from the body to body. Like you can say, degree of elasticity or degree of plasticity, that is actually the main game player here. That differs with the body. Nobody could have the ability to be defined as perfectly elastic. Nobody could have the ability to be defined as the perfectly plastic. Okay. Now, let's have a discussion over the stress. So in the beginning, I have told you, like whenever we talk about the stress, generally we go by the psychological stress. Okay. Like if you are doing some work, if you're not happy with something and you are getting the thoughts about it again and again in the negative manner, that is what we call as a stress. Okay. In the psychological manner. But in the physical manner, the stress is having the different definition and application in comparison with the psychological stress. Okay. Like we could say in physics, we could say when a deforming force applied on a body, it changes the configuration of the body by changing the normal position of the molecules or atoms of the body. Like you can say if you are having any particular ball in a circular solid shape, then the molecules or atomic position is having some normal position inside that ball. Okay. And when you are applying the deforming force, so actually you are changing these molecules and atoms normal position. Okay. So this is first thing. As a result of your changing the you can say atomic or molecular positions, an internal restoring force comes into play which tends to bring the body back to its initial configuration. So you can say suppose if this is the body, okay, and this is having some particular position of molecules, atoms and all. So now here you can say you are applying a force on it. So for example, you can say if this was the original layer or the atoms or molecules. So when you applied the force, the original layer have been down to this. Okay. So what is you are seeing? That you are actually applying a deforming force that is changing the configuration of initial position of the molecules or atoms, right? When you are doing this, immediately the internal restoring force that will come into the play. Okay. The internal force will come into the play and that force will try to take this layer to the original position from it was already. Okay. Like it was there, then you pushed it there. Internal restoring force will be pushing it back to the original place. This internal restoring force acting per unit area of deformed body is called the stress. Okay, like that is the internal restoring force of any body that try to regain the original position of configuration that was initially presented within the object before the deforming force being applied. Okay, and it is known as stress equals to restoring force by area. Okay, restoring force by area, that is the stress. If there is no permanent change in the configuration of the body, okay, like you can say the change was only temporary and no permanent change, therefore in the absence of plastic behavior of the body, like you can say if there will be a permanent change in the configuration, even after the removal of deforming force, the body won't be able to regain the original shape and size, or we can say the original configuration. Okay, because the change that was created because of the deforming force is now of the permanent nature. But if it is not permanent, it is temporary or short change, then it will be a elastic behavior. If it is a permanent change, that will be a plastic behavior. So when we are saying there is no permanent change in the configuration of the body, we are actually taking it into the consideration as absence of plastic behavior of the body. Okay, so the restoring force is equal and opposite to the external deforming force applied. Like you can say the amount of force you apply to deform the object, the same amount of force the restoring force will applying on your hand. Okay, so the restoring force is equal and opposite to the deforming force. That is the main thing that you could learn. Thus, stress S equals to external deforming force by area. Unit of stress, if we talk about this, so the SI unit of stress is Newton meter square or Pascal, and in CGS system it is Dynes centimeter cube, sorry, centimeter square. And dimensional formula stress is bracket M L's power minus 1 into T's power minus 2. Okay. Now, let's have a discussion over the types of stress, how many types of stress we have. First, that we call as a normal stress. Okay. So when a deforming force acts normally over an area of a body, okay, normally over an area of a body, then the internal restoring force set up per unit area of the body is called the normal stress. Like deforming force you have applied on an particular area of a body. So internal restoring force that will be of the opposite magnitude and direction to your deforming force also set up per unit area of the body. Okay, so that is known as the normal stress. Normal stress could be divided into the following categories. What are these categories? First is the tensile stress. So if there is an increase in the length or extension of a body in the direction of force applied, the stress setup is called the tensile stress. For example, if you are having a rubber band, okay, when you can say stretch the rubber band, automatically you are increasing the length of the rubber band. Okay, so on that time, the stress that will create in that rubber band will be a tensile stress. Got it? Compressive stress. If there is a decrease in the length of a wire or compression of the body due to the force applied, the stress setup is called the compressive stress. Okay, like if you're having a sponge ball having a certain diameter, so when you will try to crush it, automatically you are decreasing the length of that particular, or you can say diameter of that particular sponge ball. Okay, so that will be a compressive stress. There is a note. Tensile and compressive stress could also be termed as the longitudinal stress. Why? Because these are dealing with the increasement in the length in case of tensile stress, decreasement in length in the case of compressive stress. Got it? That's why these are known as the longitudinal stress. Okay. Thereafter, the hydraulic stress. So when a solid body undergoes a change in volume without any change in its geometrical shape, on applying the force perpendicular to every point on the surface of the body, then the restoring force per unit area is called in the hydraulic stress. Okay, like you can say there is a change in the volume of a body, but geometrical shape of the body after applying a force perpendicular to every point of the surface of the body is not. Okay, like geometrical shape is negligible, then it is known as the hydraulic stress. Hydraulic stress is generally possible when a solid spherical body is placed in fluid under the high pressure. Okay, then hydraulic stress was created. After this, tangential or shearing stress. What is this stress? So when a deforming force acting tangentially to the surface of a body produces a change in the shape of the body without any change in volume, then the stress set up in the body is called the tangential stress. Like you can say, now the shape of the body is getting changed, but the volume is remaining as it is. Volume is not getting changed. Then it is known as the tangential stress. Stress is also the scalar quantity. Why? Because it's only having the magnitude but not having any particular direction. After stress, now we have the strain. So the ratio of change in configuration to the original configuration is called the strain. Okay, like originally, if the rubber band having the length of, for example, 0.5 centimeter, when you stretch it, its length is now 1.5 centimeter. Okay, so which means how much change is there is the strain, like the ratio of change in configuration to the original configuration. Original configuration was 0.5, okay, and the change is 1.5. All right, so that is the strain. Strain is equals to change in configuration by original configuration. Strain being the ratio of two like quantities having no units and also no dimension. Now the types of strain. As the change in configuration involves a change either in length, volume, or shape of the body. Hence, the strain is also of three types. First is longitudinal strain. If the deforming force produces a change in the length alone and no other factors getting changed, the strain produced in the body is called the longitudinal strain. Therefore, we could say the longitudinal strain is equals to change in length by original length. So here you can say original length is being represented by L, change in length is represented by delta L. Okay, so if you go by this, you could get the ratio of change in length in comparison with the original length, that is the known as longitudinal strain. Volumetric strain. If the deforming force produce a change in volume alone and no other factor affecting, the strain produces in the body is called the volumetric strain. Volumetric strain is equals to change in volume by original volume. Okay. Now types of strain. First is shearing strain. If the deforming force produces a change in the shape of the body without changing its volume, the strain produced is called the shearing strain, which means only the shape of the body is getting changed. Volume is as it is. There is no change. It is defined as angle in radian through which a plane perpendicular to the fixed surface of the cubical body gets turned under the effect of tangential force. Shearing strain is equals to delta is equals to theta is equals to delta L by L. Thus, the shearing strain is also defined as the ratio of displacement of surface under a tangential force to the perpendicular distance of the displaced surface from the fixed surface. After this, now let's have a discussion over the elastic limit. Like, what do we understand by the term elastic limit? So elastic limit is actually the upper limit of deforming force up to which, if deforming force is removed, the body regains its original shape completely, and beyond which, if deforming force is increased, the body loses the property of elasticity and gets permanently deformed. For example, if you are having a rubber band, if you start stretching it, so there is a limit. Up to certain limit, that band having the capability to experience the deforming force, and when you leave it, okay, when the deforming force removed from it, band having the capability to regain the original configuration, right? But if you continuous stretching, okay, and if you're not removing that deforming force, and if you cross the limit, then what will happen? The plastic band got stuck and got broken, and when you remove the deforming force, even then it will not be possible for the band to regain the original shape. Okay, that is known as the permanently deformed. Okay, now the Hooke's law. What do you mean by the Hooke's law? So Hooke's law is the basic law in elasticity. Okay, it is actually the extension produced in a wire is directly proportional to the load attached to it. Thus, according to the Hooke's law, extension is directly proportional to the load. However, this proportionality holds good up to a certain limit. After this proportionality will also be impacted, and this certain limit up to which this proportionality holds good is known as the elastic limit. Got it? That was the year of 1807 when English psychist Thomas Young pointed out that the load and the extension are more scientifically described in terms of stress and strain, respectively. Thus, Hooke's law may be stated that stress is directly proportional to strain. According to the modified forms of Hooke's law, stress is directly proportional to strain. Stress equals to constant into strain, and constant equals to stress by strain. This constant of proportionality is called the modulus of elasticity or coefficient of elasticity of the material. If the value depends upon the nature of material of the body and the manner in which the body is deformed, then you can calculate the accurate value. There are the three moduli of elasticity, namely Young's modulus Y, bulk modulus small k, and modulus of rigidity presented by small m, corresponding to the three types of strain. Young modulus, it is defined as the ratio of normal stress to the longitudinal strain within the elastic limit. Thus, Y equals to normal stress by longitudinal strain, or Y equals to FL by AL, where F by A equals to normal stress and small l by the capital L equals to longitudinal strain. If wire has got a circular cross section of radius r, then Y equals to FL by pi r square L. The unit of Young's molecules are Pascal or nanometer square in SI and dyna centimeter square in CGS. Its dimensional formula is mL's power minus 1 into T's power minus 2. Note, Young modulus is involved in solids only. So with this, we have finished the you can say topic, not part for the summary discussion. So we have talked about the deforming force, elasticity, perfectly elastic body, perfectly plastic body, stress, types of stress like normal stress, hydraulic stress, tangential stress, strain, longitudinal strain, volumetric strain, shearing strain, elastic limit, Hooke's law, modulus of elasticity. So with this, we have finished this lecture. It is requested to all of you kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.